Hello friends, in this session we'll study about carbocations. Carbocations are the intermediates formed during an organic reaction. Now this picture also shows a carbocation. This is a carbon atom with a positive charge. So we'll be studying about carbocations in this session. Carbocations are electron deficient. Because of this, carbocations are Lewis acids. Now, a group of atoms with a positively charged carbon atom having 6 electrons in the valence shell after sharing is called as a carbocation. Right? That is a carbon atom having 6 electrons in their valence shell after sharing. Now, how can this be formed? A carbocation may be formed by heterolysis of carbon and halide bond in alkyl halides. So it can be formed by many different ways, but this is one of the common way. Right? So heterolysis, in this type of cleavage, what happens? The shared pair of electron moves to one atom. Right? So this is a tertiary butyl chloride, and the carbocation formed over here is a tertiary butyl carbocation. Now let's see the orbital structure of carbocations. The positively charged carbon atom is sp2 hybridized. That is 3 orbitals, 1s and 2p orbital hybridized to give 3 orbitals of equal energy. Right? Now the hybridized orbitals, they form sigma bond with the monovalent atom. And these two are the unhybridized orbitals. Right? So a carbocation is sp2 hybridized, and what is the bond angle between them? It's 120 degree. And what should be the structure of it? It's a planar structure. Now the types of carbocations. This is a methyl carbocation. That is, it is a methyl group, and the carbon atom is having 6 electrons in its valence shell. Likewise, this is an ethyl carbocation, right? Or these are also called as primary carbocations. Now, this carbocation is an isopropyl carbocation or a secondary carbocation. When the carbon with a positive charge is bonded to 2 carbon atoms. Likewise, there is a tertiary butyl carbocation, when a carbon atom having positive charge is bonded to 3 methyl groups. So these are different types of carbocations. Right? This is just an example: primary, secondary and tertiary. Now what is the order of reactivity of carbocation? Primary carbocation is more reactive than secondary carbocation, and it is more reactive than tertiary carbocation. Now if I take up the order of stability, it is the tertiary carbocation is more stable than secondary, and it is more stable than primary. Now let's see the reason behind. See, carbocation is what? It is a positively charged carbon atom which is electron deficient. Right? It is also a Lewis acid. Now this is stabilized by 2 of the effects. First is the inductive effect. Now what is the inductive effect? It is the electron releasing or electron withdrawing effect in a carbon chain. Now the alkyl groups, they have got plus I effect. That is, they have the electron releasing effect. Now due to plus I effect of alkyl groups, that is the electron releasing effect, the electron density on positive charged carbon atom increases, thus decreasing the positive charge on the carbon atom. See, if I take an example of tertiary butyl carbocation, see, this was what? There is a methyl group. Again, to the carbon atom there is a methyl group. There is again a methyl group, and there is a positive charge. So how many alkyl groups are there? There are 3 alkyl groups bonded to the positively charged carbon atom. Right? Now what happens, students, or what happens, friends? The electrons are released towards the positively charged carbon atom, as the result of which the alkyl groups gain a slight positive charge. Right? Now, due to this, what has happened? The positive charge has been delocalized on the whole molecule. Right? And more is the delocalization or dispersion of the charge, more is the stability. In case of primary carbocation or methyl carbocation, such charge dispersion is not possible. See, there is only one alkyl group over here bonded to the positively charged carbon atom. In methyl group, in methyl carbocation, there is none of the alkyl groups. So, more is the inductive effect, more is the stability of carbocation. Likewise, there is another thing, that is hyperconjugation. The number of hyperconjugated structures for a particular carbocation depends on the alpha hydrogen atoms present. Stability of carbocation is directly dependent on the number of hyperconjugated structures. Now, what is hyperconjugation? In this case, what happens? The sigma electron of the carbon hydrogen bond conjugates with the vacant p orbital of this carbocation. And this hyperconjugation is also known as Baker and Nathan effect or no bond resonance. So, more is the number of alpha hydrogen, more is the number of hyperconjugated structures. If I take up these three alkyl groups, so how many alpha hydrogen are there if I take up? It's CH3. And again, there is a CH3 and CH3. If there is, say, 3 CH3 molecules, then how many alpha hydrogen are there? There are 9 alpha hydrogen atoms present. So, how many hyperconjugated structures? 9. And so, more is the stability. So, students, the stability of carbocation depends on the inductive effect as well as the hyperconjugation, right? Now let's see the decreasing order of stability of carbocations. So these are given carbocations over here. Now this is what tricyclopropyl carbocation is more stable than bicyclopropyl carbocation. Now why is it so? In case of, say, tricyclopropyl carbocation, how many alpha hydrogen are present? There are 6 alpha hydrogen. Right? So how many hyperconjugated structures possible? 6. Whereas in bicyclopropyl, how many hyperconjugated structures possible? 4. So which is more stable? Tricyclopropyl carbocation. Now see, this is triphenyl carbocation and then biphenyl carbocation. Triphenyl carbocation, this will be more stable due to resonance. Then biphenyl carbocation, then this carbocation, this benzyl carbocation. Then is allyl carbocation. Because of the resonance stability, it is more stable than tertiary. Tertiary carbocation is more stable than secondary carbocation. It is further more stable than primary carbocation and then methyl carbocation. Right? So, allyl carbocation is more stable than tertiary carbocation because of the resonance also. Right? So, this is about the decreasing order of stability of carbocations. The stability of carbocations is affected by the inductive effect, the second is the hyperconjugation and the resonance.